Imagine a construction crew showing up to an empty lot to build a skyscraper, but nobody brought the blueprints. People bump into each other, stairs lead to nowhere, and the entire project turns into a chaotic mess. If a team of developers tries to build a massive computer program without a master plan, you get the exact same result. People duplicate work, parts don't fit together, and eventually the whole system collapses under its own weight. That's where software architecture comes in. It is the big picture master plan created before a single line of code is ever written. A software architect steps back and maps out every single digital element. They figure out exactly what each piece does, and crucially, how all those pieces will talk to each other. Having this clear map prevents developers from stepping on each other's toes with quick, messy fixes. Instead, everyone gets a solid, organized foundation to build upon. So, just like a physical skyscraper, a reliable digital app is never randomly typed into existence. It has to be deliberately designed from the top down. Before drawing up any plans, a good architect has to ask a few basic questions. They need to figure out exactly what the finished building is actually going to be used for today. Think about it. A cozy family home prioritizes comfort and big windows, while a downtown bank prioritizes thick vaults and security cameras. The purpose completely dictates the design. Building software involves a similar mix of people with very different needs. You have the clients paying, managers keeping it on schedule, developers writing the code, and finally the everyday users. A successful piece of software takes all of these different and sometimes competing needs and balances them in the final design. But how do you actually draw a building that's made of code instead of steel and glass? To solve this, architects use a special kind of visual blueprint. They are used by engineering teams everywhere to see the skeleton of an app. This diagram shows how we represent these structures. These charts strip away all the messy code and break the application down into simple shapes representing actions, with arrows showing how information flows between them. These visual models act as a universal language. They let the entire team gather around and easily spot where a digital bottleneck might happen, or where the system might fail under pressure. Mapping out these abstract lines and boxes lets the entire team safely test how everything will work together, long before they spend time and money actually writing the software. Physical buildings have distinct, recognizable styles. A towering high-rise looks very different from a sprawling ranch house. Software systems have distinct styles too. One style works a lot like the floors in a hotel. The user interacts with the pretty lobby on the top floor, while all the heavy, secure processing hums away quietly down in the basement. Then you have an entirely different approach, one that focuses purely on a strict hierarchy of commands. We can think of this as a master program that gives orders to smaller, specialized tasks. This chart shows exactly how that hierarchy looks. Everything starts right here in this top box, the brain of the system. When a command is given, it travels downward, triggering a specific task, which branches out to trigger even smaller, specialized subtasks below it. The style an architect chooses here completely dictates how the final system will behave, how easy it will be to update, and how well it can grow in the future. Ultimately, an architect doesn't type out the individual lines of code. Their job is to create the overarching organization that holds all those lines together. Good architecture also handles the hidden requirements, the stuff that makes an app feel solid and reliable. We're talking about things like ironclad security, lightning-fast speed, and making sure the app is actually easy to navigate. Software developers rely on these broad architectural guardrails to keep the project on track. As new features are added over the years, these rules ensure the system stays consistent and doesn't break. Remember our skyscraper? A well-built house won't collapse in a storm, and well-built software won't freeze up just because you asked it to download a file and swipe to the next screen at the exact same time. The seamless, crash-free applications we rely on every single day aren't magic. They are the direct result of careful, invisible software architecture.